There is a dry joke among researchers, often scrawled on lab whiteboards or murmured over conference coffee. Immunology is where intuition goes to die. Most of us picture our internal defenses as a highly coordinated military force, a logical shield designed strictly to identify and repel invaders. The COVID-19 pandemic forced billions of people to try and apply that simple logic to viral immunity and antibody dynamics, and they discovered painfully that the system operates on logic that is layered, conditional, and deeply non-obvious. To actually understand how our bodies survive, we have to systematically destroy three common-sense assumptions about human biology. We assume biological defense means keeping our tissues perfectly safe from harm. In reality, a fever is a deliberate escalation. Your hypothalamus cooks your own cells to make the environment hostile to a pathogen. Inflammation floods a wound with immune cells and fluid, knowingly damaging local tissue. That Fraubeing swelling is tactical demolition. When this willingness to sacrifice tissue loses its off switch, we get autoimmunity. The machinery built to keep you alive identifies your own organs as foreign threats and turns its weapons entirely inward. This internal friendly fire affects roughly 5 to 8% of the global population, and the numbers are steadily rising. The idea that a stronger immune system is automatically a healthier one falls apart completely when those defenses are aimed at you. Our second assumption is that foreign bodies are absolute threats, and a sterile environment is the healthiest baseline. The hygiene hypothesis suggests the exact opposite. Because we co-evolved with soil bacteria and gut microbes, an immune system deprived of dirt loses its sparring partners. It gets confused. It starts attacking harmless dust mites and PMIT proteins, triggering severe allergies. But the ultimate subversion of this border control logic is pregnancy. A developing fetus carries half its genetic material from the father. It is immunologically foreign, a living 9-month organ transplant. The mother's body doesn't reject it because the placenta creates a localized zone of immune suppression. Fetal tissue actively secretes molecules that disarm incoming maternal defenses, while regulatory T cells enforce a highly negotiated truce between two distinct genetic codes. Survival relies on a razor-thin balance between ruthless defense and an equally sophisticated system of biological tolerance. We tend to think a long life builds an invincible library of experience, offering a superior shield against new threats. Yet, when confronted with a completely novel respiratory virus, young children with abundant, naive T cells that had never seen a pathogen adapted rapidly and cleared the infection. Older adults suffered the worst outcomes. Their systems were bogged down by a massive repertoire of memory cells trained on decades of past familiar infections. They possessed deep experience, which made them sluggish and dangerously inflexible when facing something entirely new. For decades, textbooks claimed only these slow, adaptive memory cells could learn, while the fast-acting innate immune system was completely memoryless. We now know the innate system uses epigenetic reprogramming to alter its own genetic access. In 2025, researchers at the University of Cologne discovered that mRNA COVID vaccines caused persistent epigenetic changes in monocytes. Because these cells only live a few days, the vaccine was actually reprogramming the bone marrow factories that produce them, leaving an imprint for months. This accidental, heightened state of alert had an astonishing side effect. Cancer patients who received mRNA vaccines right before starting immunotherapy were twice as likely to be alive 3 years later. Wondering, a shot designed to treat a respiratory virus inadvertently trained the innate immune system to recognize and hunt tumors. Memory lives where we least expected it. Human immunity is a breathtakingly sophisticated ecosystem operating on razor-thin margins. Defense frequently looks like an attack. Amnesia provides an advantage, and exposure to dirt builds stability. Now we are subjecting this fragile ecosystem to the ultimate stress test, astroimmunology. In the microgravity and high radiation of orbit, immune surveillance drops. Astronauts regularly see latent viruses, like Epstein-Barr, wake up and reactivate because the body's normal suppression mechanisms fail. On multi-year missions to Mars, protecting human immunological stability represents a massive engineering bottleneck. Getting off this planet and surviving here on Earth requires us to abandon our simplest assumptions and embrace the beautiful, baffling paradoxes of human biology.